in this video, I'm going to discuss the graphical method of finding the limits. It means we will look at the graph and we will try to figure out the values of the limit. So for example, in this example 1, so let's say we want to answer the question that what is limit x approaches to 5 fx? So this is what we're going to try to figure out. So this function is a stepwise function because there is a jump discontinuity. And in order to figure out limit x approaches to 5 fx, it means we need to look at both sides of 5 and see what happens to the value of function in the neighborhood of 5. So first we'll try to figure out limit as x approaches to 5 from the negative side and what happens to the function, and then we'll figure out limit as x approaches to 5 from the positive side and then see what happens to the value of the function. So let's take a look. So when x approaches to 5 from the left or from the negative side, so we notice that the value of y approaches to 4, correct. So the function, the value of y is approaching to 4. Similarly, if we look when x approaches to 5 from the positive side, and we can see that the value of y or the value of the function is also approaching to 6. And in this case, so although the one-sided limits exist and we have a finite value for both one-sided limits, but if we notice that the values 4 and 6 are not equal. So one-sided limits exist, but in actuality, the conclusion would be the limit of x approaching to 5 f of x does not exist. So DNE stands for does not exist. I'm going to use this notation again and again in my videos. So please remember. So it means does not exist. So because previously in the previous video, we discussed that for a limit to exist, both the one-sided limits should exist, and their value should be equal. If the values of one-sided limits are not equal, then we say that the limit at that point does not exist. All right, let's take a look at another example. So take a moment to figure out all the values of the limits that they have asked here. So in this example, first of all, let me just define the scale on the x-axis. So let's say this is 2, 4, 6, -2, -4, -6. So this will help us to figure out the limits. So first one is limit x approaching to -1. So -1 and from the left or from the negative side of gx. All right, so let's take a look here. So we are going to approach -1, x is approaching to -1, and what happens to the y value? So as x is approaching to -1 from the left, so we see that the y value is, what happens to y value? So it is approaching to positive infinity. So we can say that this is positive infinity. All right, so next we have limit x approaches to -1 plus. So now we are looking at this one. So In this case, so if you approach to -1 from the positive side, so what happens to the y value? So we can see that again, the y value is approaching to infinity. So again, we say that y value is plus infinity, or you can just write infinity. So I'm just putting positive to show that it's going towards positive infinity, or just infinity, same thing. All right, so let's move on to our next part. So when x approaches to 0, so here is our 0. So when x approaches to 0 from the negative side, so 0 from the left, so it means when x is approaching to 0 from the left, we are looking at this part, and again we can notice that the value here is the y is approaching to 0, so the value of y is just 0. Next one is when x approaches to 0 from the positive side. All right, so x approaches to 0 from the positive side. So here is our positive side. And if we notice that when it's approaching to 0, so where does the y value goes? The y value is approaching to negative infinity. All right, so let's take a look at the next case when x is approaching to positive infinity. So when x is really big, so what happens to the y value? So y value is, so no matter x is however big x gets, the y value is approaching to a particular value of y, so a finite value of y. So it's not given here, but I can tell you, so this was 4, so y is, or the value of the function is 4. So when x approaches to infinity, so we say that the value of y approaches to 4. Now let's take a look at our last case. Limit x approaches to negative infinity, gx approaches to what? So we can see that as x approaches to negative infinity, it means we are looking in this direction. So when it happens, we can see that gx is almost, it becomes closer and closer to y equals to 0. So the value of the function approaches 0 as x approaches to negative infinity. So in this case, we say that the answer is 0. Let's take a look at another example just for practice. So we are given this, again, this is a piecewise function because prior to 2, so when x is less than 2, it's defined with a different function. When x is greater than 2, it's defined with a different function and different expression. And when x is 4, so it's given already that the value is approximately 3. The dot shows the inclusion and the hollow circle shows the exclusion. All right, so let's work with it. So the first thing that we need to figure out is limit of fx as x approaches to 0. All right, so one thing we know that whenever we talk about approaching to 0, so we're going to take a look when it approaches to 0. So this is our 0. So when it approaches to 0 from the left side as well as limit when x approaching to 0 from the right side. All right, so when x approaching to 0 from the right side or the positive side, so we will see that the value of the function is or the y value is approximately -3. Let's say it's -3. Similarly, we can figure out what is the limit as x approaches to 0 from the negative side. So if we go from this side, again, we will notice that the y value approaches to -3. And we know that these both limits agree. And once if they agree to each other, so they agree, it means the limit x approaching to 0 exists, and the value of that should be -3. So it comes from here. Alright, so let's discuss what happens next one when x approaches to 2. So limit x approaching to 2. So again we can try to figure out the two parts. So limit as x approaching to 2 from the positive side. Okay, so from here. So what happens to the y? So y is approaching to 2. So the function's value is 2. Similarly, we can take a look. Limit x approaching to 2 from the negative side, and then see what happens to the y value. So if we approaches to 2 from the negative side, so we can see that the y value of the function, so the y value of the function is approaching to -4. So if we look at these two cases together, so we can deduce that these two limits do not agree. We don't get the same answer for both one-sided limits. So that implies that this limit does not exist. Next, we discuss what happens to the value of function at 4. So we can clearly see when x is 4, the y value is 4. The function y value is 3. So the function value is 3 according to the graph. So this solid black dots show us the value of the function corresponding to x equals to 3, x equals to 4. So in order to summarize, we can say that limits extended our knowledge about functions, extended our knowledge of functions, and for a limit to exist, so we should have both-sided limits should exist and they should be equal. So graphically, in order to graphically determine the limits, graphically finding the limits, so we should look at both sides. So limit of x approaching to a from the positive side, so limit of the function, and limit of x approaching to a from the negative side of function. So they both should exist individually, and but also not only exist, they should agree with each other to the same value. So if they agree, we say that limit exists closer to a, as x approaching to a. But if they do not agree, so then we say that limit does not exist. Thank you for watching. So in the next videos, I will discuss the other methods of finding the limits. So keep watching.